Connor I will help you do your math. He is very, you will say. Slay, 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 math.
Hi everyone, and welcome to my YouTube channel. Ever find math textbooks or math packets daunting, incomprehensible? Well, don't worry. Although math surely is a daunting subject, my videos will cover each concept in easy and simple portions. For now, I'll start with the concepts in trigonometry. First of all, there are three definitions of trigonometry. The first definition is the right triangle definition. In trigonometry, a trigonometric function relates the sides of a triangle to an angle. It expresses an angle as the ratio between different side lengths. The second definition is the unit circle definition, which is this one. And the unit circle definition serves to explain trigonometry in terms of x and y coordinates within a unit circle. So for example, the coordinates of this point would be the sine and cosine of a certain angle. The final definition is as a function. So the function here is simply y equals sine x. However, what's special is that we can think of y equals sine x interchangeably as if it was y equals x squared. The slay thing about this is that whenever we have an input as an x, we are always able to generate an output y. Just as if we're always able to generate an output y when given an input of x in y equals x squared. And this is extremely good because we can perform algebraic manipulations on geometric definitions. In other words, trigonometry is extremely slay because it connects algebra and geometry in a very interesting and unique way. So for today, we'll start by exploring the right triangle definition. Okay. So for now, what I'll be doing is I'll introduce some definitions of trigonometry, and because it's hard to remember them, I'll give some mnemonic devices. So if I define the three sides as A, B, and C, C being the hypotenuse, I can also define angles as B, C, and A as shown in the picture. So as I just said, sine or trigonometric functions express angles. For example, it expresses angle alpha here as the ratio of two sides. So it relates angles to sides. So for example, the first trigonometric identity that I will introduce is sine. What sine does is it takes the opposite side of the angle and divides it by the hypotenuse. And note a few vocabulary terms here. First, the first vocabulary term is opposite. The opposite side is the side that is, opposite to the angle. So for example, the opposite side would be, for angle A, would be A. While the hypotenuse is, the side that's longest. But one thing to take note is that the opposite side, because trigonometry never takes account into the right angle, the opposite side will never be the hypotenuse, which is very interesting. Well, it does take into account the right angle, but that will be discovered later in the unit circle and as a function. So sine is opposite over hypotenuse. That's the first function. Second function is cosine. Let's take the same triangle and the same angle measure of A. Cosine, on the other hand, does the adjacent over the hypotenuse. And again, one more definition. The adjacent side is always the side that is adjacent to the angle, but with a caveat. It is never the hypotenuse. So for example, there are two sides that are adjacent to A. This side, which is C, and this side, which is B. And here the adjacent side is always B because it is the side that is not the hypotenuse. So again, cosine will, for sure, I'll just write C here. Cosine is always adjacent over hypotenuse. And the final trigonometric identity that I will introduce today is tangent. So tangent is the opposite over the adjacent. So for example, in the same triangle, if I have angle A here, note how tangent is the opposite over the adjacent. However, what is also opposite over adjacent? Opposite over adjacent is simply the sine over the cosine. So this is one way of thinking about it, but it's also simply sine over cosine. So these trigonometric identities are essential for not only understanding future trigonometry, but it's also essential for future studies in polar equations and many others. So a mnemonic device that I use here is SOHCAHTOA, right? So let me write that down for you. In my opinion, this is a great mnemonic device because one, it's easy to say, it's easy to remember, but also incorporates the different trigonometric values together, which is also really slay. Yeah, and that's all for today. If you really liked the video, please like, subscribe, and comment, and see you next time. Bye!